Hello, my name is Jeff and welcome to Thermodynamics 101. So again, maybe you are coming from my blog or maybe you've just searched this topic on YouTube, but you don't need to worry again. I'm here to explain to you one of also important topic here on thermodynamics because it is heat. Because thermodynamics is related to heat in work, right? There will be three discussions. First is for a specific heat, second is for latent heat, and for the third one is for the heat transfer. Sometimes we interchange the meaning of heat and temperature, but for clarification, temperature is just a relative measure of hotness and coldness of a substance, and heat is energy in transit. So basically, the temperature is just the measurement of heat on a system. And in temperature, we have the units of Celsius, Kelvin, and Fahrenheit, but in here we have joules or calories. Here are the sample problem for specific heat.
How much heat is required to raise the temperature of 0.37 kg of water from 19 degrees Celsius to 42 degrees Celsius? Given that you have a specific heat of water 4186 joule per kilogram Celsius, mass of 0.37 kg, initial temperature 19 degrees Celsius, and final temperature 42 degrees Celsius. Given that you have the formula of heat, which is m times c delta T, substitute all the values that you have, you will be having 0.37 kg times 4186 joule per kilogram Celsius times 42 minus 19. You will be having 25 kilojoule.
So that is specific heat. However, sometimes even though we add heat on the system, there will be no change in temperature. You heard it right. Yes, that is possible. Even though we add heat, there will be no change in temperature because that is what we call latent heat. So this is a sample problem for latent heat.
Calculate the amount of heat added to 24 grams of gold to change phase from solid to liquid. LF for gold is 64.5 times 10 raised to 3 joules per kilogram. Given that the latent heat of gold is 64.5 times 10 raised to 3 joules per kilogram and your mass is 0.024 kilogram. So for the solution, you will have a formula of Q is equals to ml of gold, 0.024 kilogram times 64.5 times 10 raised to 3 joule per kilogram. And the answer is 1,548 joules.
Okay, you already know what is the meaning of latent heat. I'm sorry that I forgot earlier to say that even though we add heat, there will be no changes in temperature. However, there will be a phase change happening on the system. So it could be solid to liquid, liquid to gas, or gas to solid. That is possible. Here's the different phase changes in solid, liquid, and gases. In order for us to see in a graphical form, I prepared here a graphical representation of heat versus temperature. Just take note of that one because it might help you to understand better some worded problems here in thermodynamics. It is possible also that the specific heat and latent heat is in one situation or one worded problem, okay? So I think guys, you have enough knowledge about the specific and latent heat. So what we're going to do is to move forward and let's see what are the heat transfer or the types of heat transfer. But before that, what is heat transfer? types of heat transfer. First is conduction, second is convection, and third is radiation. The first type of heat transfer is conduction. Okay, if you hear the word conduction, what comes first to your mind? Or what do you think first? Because me, if I think conduction, it means colliding, or intact to each other, right? So here's the meaning of conduction. The second type of heat transfer is convection. Convection, if I heard that word, I barely understand what is the meaning of that. So here's the meaning of convection. Thirdly is radiation. Radiation, as far as I know, concerns more on molecules, right? Okay. Now that we already know all the types of heat transfer, here is an example or a real life example of heat transfer. So we have here a pan, we're going to boil the water, and we have here a bonfire, or actually it is not necessary to be a bonfire. It can be a gas stove, or it could boil on a gas stove, right? Let us just start with this part, because we know that the heat is coming from this bonfire, or this fire. This fire will represent the radiation heat transfer, because the heat of the molecules upward is transferring the energy from the fire to the pan. If the pan is heated, it will increase in temperature, right? And the movement of the molecules in a liquid, or the kinetic energy of the particles in the liquid, is the convection part, or the convection heat transfer, because convection is more concerned on heat transfer that is related with a liquid. And lastly is the conduction. We'll see that the heat of the pan, or the gained heat of the pan, it will be transferred to the handle. And that is just the conduction, because conduction is more related or more concerned on the attachment of two objects or two substance. So it could transfer heat. I'm sorry. Here are some thermodynamics terminologies. You might write it down, you might put that in your notes in order for you to have a future references. Okay, now we're all done on the topic heat and thermodynamics. I hope you guys learn, and I hope you also visit my blog in order for you to have an additional knowledge about thermodynamics. I will link down below the thermodynamics blog. Thank you.